Well, hey guys. So yesterday I started working on this beautiful thing right here. This is going to be a forced air ribbon burner gas forge. I think I said that right now. All right. So yesterday I got the frame all taken care of. It's welded to this base plate, which is just resting on this cart for right now. Later I might decide to weld it to the cart. I don't know right now. I want to be able to break down if I need to, as much as I can. Because this sucker's going to weigh a gall darn ton, as it were, once it's all finished. Today, what I'm going to do is I have traced around the outside of that ribbon burner, and I am going to cut out that slot right now. Probably after that's done, I will find up some angle iron and weld right across the top here, just down from the top of that ribbon burner. For two reasons. One, I want it way up here so that it doesn't break up with the extreme heat from machine welding. It doesn't break up any of the concrete down here, the refractory that was used in casting this ribbon burner. I am actually using a purchased ribbon burner. I purchased this one from Essential Craftsman. Mostly because I've never tried it before. I've never tried one out. I don't know what they're like. I know they're supposed to be a whole lot more efficient. So, first one I'm going to use a store-bought one just to take my incompetence as far as a burner maker out of the equation. Anyway, so need a flange welded on either side here. Angle iron will work great for that, so that once this hole is cut, it can pass through into the forge cavity. Once that is all done, I'll take and line the inside. I have both castable refractory, and I also have some koawool, and then I've also got a bit of ITC 100 that I'll go over everything. But what will happen is, once this is in place, I will fill it with the koawool first, at least one layer, probably two. It is 2-inch. So what'll probably happen, I was thinking about this last night, is one layer of koawool on the floor, 2 layers on the walls. That'll give me 4 inches of thickness all the way around, except for the floor. Then I will take that castable refractory and put a layer over top of that, and probably going to be pretty thick with that stuff because, it has a tendency, as it cures and dries out, to break and whatnot. But it works phenomenally. So from that, I will then take that ITC 100, mix it up in a real thin slurry, and apply it directly to the castable refractory from there. So we'll see what the finished measurements actually are. But yeah, anyway, enough chit chat. I'm going to go ahead and get started. I am going to cut this with my Cut 50 plasma cutter. So I am going to move this out of the way. Put it under the camera because that's going to be the safe spot. Detach the welder, get it out of the way. Yeah, I know. Clean up your workspace. Yes, safety officer. Anyway, so we will attach our clamp. Probably going to get a little loud. I might wind up muting this part in the video. So, yeah. Because for the plasma cutter to work, I have to have an air compressor. So that didn't take terribly too long. Put these on and show you what I got going on here. Okay, so, oh yeah, still warm. So what I did, I welded 4 pieces of angle iron on there just to cover any gappage. Now it slips right in there. We got no problems. So yeah, all right. That's the fun part of that. Let's see. Next step is busting out the koawool. That stuff, just a hazard reminder for everybody. Don't breathe it as you're cutting it. In fact, you need a respirator on when you handle it. You need to have a respirator and very good ventilation too. What'll happen is I'm going to put on a dust mask. I won't really be able to talk very much. And I'm going to turn on the ventilator here, the exhaust fan. And then I'll pull out the box and cut it open. And yeah, so enough talking, let's do it. So, let me show you the inside of this thing now. So, yeah, you got 24 inches of length, and it is now 11 inches across and 7 inches tall inside of there. And we got a layer of stuff. It's called Satanite that we're going to mix up, and we're going to coat the inside of that and make it so that as it heats up, when you heat up the inside of a forge, if it's not been at least rigidized, preferably coated in Satanite, the little ceramic fibers. They break out. It's very friable, is what it's called. But they float, and you breathe that stuff in, and it will give you cancer. So bare minimum on these forges, on these gas forges, absolutely necessary that if they use koawool, which most of the ones for sale do, you take and coat it with a rigidizer. It's even better if you use Satanite. Personally, I like to use a ceramic clay or something like that. Pottery type supply houses have that stuff. But somebody told me Satanite works better. I'm going to try it and see. I don't know. That little box was, it's a 5-pound box, and it was like 35, 40 bucks. So, you know, and hopefully it should do all of this plus some. If not, I've got some other stuff over in the corner, some of the ceramic stuff. The difference is the ceramic stuff has larger, almost like a, the stuff that we use, it's a gardening product, perlite. It's got larger pieces of perlite in it, and vermiculite. There we go. It's got a different texture to it. I used it on the big 2-burner gas forge that I built previously, and I can't get it to fine tune, but here, let me show you what that stuff looks like once it's cured. This was a piece of the door that got too hot and misshapen and fell out, but it's like concrete almost, but you know, it can handle the thermal cycling, supposedly. I think that failure was my fault because I didn't put anything to hold up the wool inside of it, which I'm going to do next on this thing. I think I'm gonna pull that wool back out, stuff it in a bag. Now that I have it cut and fit, I can weld some little keeper rods all the way around the inside of the shell, make it like a reverse porcupine, and yeah, and then that'll hold all that stuff up. Then I'll get a little bit of stainless steel wire extruded mesh fit up on the inside of that bad boy, and then mix up my plaster stuff, coat over that. You know, probably going to wind up losing an inch or so all the way around. And then, yeah, then I can work on the plumbing bits, which I need to get an elbow and probably 2 or 3 elbows, so that it can come off the top of that bad boy, 90 over, come 90 down, and go to the underside of that tray where I'll have my little, that cart, underside of that cart, where I will place the fan and blower for this forced air forge. And yeah, magic will happen after that. So, whoop, sorry. So yeah, thanks for coming out. Thanks for seeing. I guess it's really part 2, but I didn't do a video on part 1, so this is part 1 of my ribbon burner forge. Yeehaw! Hey, so yeah, I told you wrong. This stuff isn't satinite or satanite. It's actually a different brand, but it is actually supposed to be for use in forges and furnaces. Let's see. It's rated for up to 2,800 degrees, a little bit more there, you can see. But yeah, and it wasn't 5 pounds, it was 12.5 pounds. So yeah, anyway, let's see if I pause on there for a little bit, you can read it all. But there you go. Suitable for pizza oven, dome construction, furnace lining, fireplaces, outdoor fire pits. Works if used to fill cracks and holes existing factory lining. Yeah, so, but Oh, on the packing slip, it says high-tech product, furnace, foundry, fireplace, oven, stove, forge. Yep, castable refractory, rated up to 2,800 degrees there. Yeah, okay, so yippee.